Truck buyers often expect reliability and durability above all else. Whether it's a light-duty pickup used for commuting or a heavy-duty workhorse built for towing, the assumption is the same. Truck engines should last for hundreds of thousands of miles. But for some unfortunate owners, that expectation is shattered long before they reach even 30,000 miles. How does this happen? In this comprehensive deep dive, we'll explore the reasons behind early engine failures in trucks, examine what the experts say, and outline what owners can do to protect their investment. 1. Understanding early engine failure. What is considered early engine failure? Most truck manufacturers engineer engines to last at least 150,000 to 200,000 miles, with some diesel engines capable of surpassing 500,000 miles. So when a truck engine fails before even reaching 30,000 miles, essentially still within the factory warranty, it's not just early, it's catastrophic. This kind of failure often leads to engine replacement or full rebuilds, both of which can cost thousands of dollars. It also results in downtime, frustration, and often a long fight with the dealership or manufacturer for warranty coverage. 2. Major causes of engine failure before 30,000 miles. 2.1. Manufacturing defects. One of the most common causes of premature engine failure is a flaw that occurred during manufacturing. These defects might include improperly machined parts, flawed valve assemblies, faulty seals, or poor calibration of the ECU, engine control unit. Auto engineer Chris Messer, formerly with General Motors, states, "A lot of early failures are not about how the owner drives the vehicle. They're baked into the engine before the truck even leaves the factory. It's the kind of failure that can show up after just a few thousand miles." Manufacturers often address these issues through recalls or technical service bulletins, TSBs. But sometimes the problems aren't widespread enough to catch attention, leaving some truck owners unlucky. 2.2. Poor lubrication and oil starvation. Even the best designed engines will fail if they don't receive proper lubrication. Oil starvation can result from clogged filters, faulty oil pumps, or blocked oil passages, causing rapid wear of internal components. Dr. Tina Wernick, a mechanical engineering professor specializing in tribology, the study of friction and lubrication, explains, once you have metal-on-metal contact due to lack of lubrication, it's only a matter of time before bearings seize or the crankshaft gets damaged. Even 10 miles of poor lubrication can be enough to start a death spiral for an engine. Some engines have poorly designed oil passages that trap debris or restrict flow. Others suffer from overly long recommended oil change intervals that don't match real-world driving conditions. 2.3. Overheating. Cooling system failure is another major culprit. If a water pump fails, coolant leaks, or a thermostat sticks closed, overheating can warp heads, crack blocks, and ruin gaskets. Modern engines operate at higher temperatures and tighter tolerances than older models, so they're less forgiving of heat spikes. Brian Anders, a powertrain development lead at a major truck manufacturer, adds, "We've seen cases where a plastic impeller in a water pump fails and causes overheating, and within minutes, the head gasket blows. If that coolant gets into the combustion chamber, you're looking at serious damage." Unfortunately, not all overheating issues trigger a clear warning before the damage is done. 2.4. Timing chain or belt failures. Another problem plaguing modern engines is timing chain or belt failure. If the timing chain stretches, breaks, or jumps a tooth on the cam sprocket, the result is often catastrophic valve-to-piston contact, especially in interference engines. Some manufacturers, in an effort to reduce noise and cost, use lighter or lower quality timing components that don't hold up under real-world use. According to Peter Valdez, a master mechanic certified by ASE and a contributor to the Truck and Tow Journal, "I've seen multiple 5.0 V8s and EcoBoosts lose their timing chains before 30,000 miles. Once that goes, the engine's toast unless it's caught immediately." 2.5. Design flaws in modern engines. In the race to improve fuel efficiency and emissions, some manufacturers have adopted high-tech solutions that inadvertently make engines more fragile. Turbochargers, variable valve timing, cylinder deactivation, direct injection, all great on paper but complex and often unreliable in practice. James Harcourt, an auto industry analyst, notes, "The complexity in today's engines is exponentially higher than even 10 years ago. Every additional moving part is another point of potential failure, especially if cost-cutting compromises durability." Cylinder deactivation systems in particular have come under fire. While they improve fuel economy, they also create uneven wear patterns and are often associated with oil consumption issues and lifter failures. 2.6. Incorrect fluids or maintenance mistakes. Many early engine failures can be traced back to improper maintenance, sometimes due to the owner and sometimes due to dealership negligence. Using the wrong type of oil, overfilling or underfilling, or ignoring service intervals can cause rapid engine wear. Some trucks require full synthetic oil or specific viscosity grades, especially turbocharged or direct injection models. Others have unique coolant formulations, and mixing the wrong types can cause corrosion or gelling. One case study involved a Ford F-150 EcoBoost, whose engine failed at 18,000 miles because the dealership used the incorrect oil grade during 2 consecutive services. The turbo seals failed, flooding the intake with oil and starving the turbo of lubrication. 3. Expert analysis on brand and model trends. While no brand is immune to early engine failure, certain manufacturers and models have shown more consistent problems in recent years. Ford EcoBoost engines. The 3.5-liter and 2.7-liter EcoBoost V6 engines have had known issues with timing chains, carbon buildup, and condensation in the intercooler. Ford has addressed some of these problems with revised parts, but early models remain problematic. Travis Donnelly, an engine failure analyst, remarks, "The EcoBoost is brilliant in theory, but complex. We've seen failures under 30,000 miles in trucks used for towing or with poor maintenance histories. The margin for error is razor thin." GM Active Fuel Management, AFM. GM's AFM system has been linked to premature lifter collapse, valve train failures, and excessive oil consumption. In some cases, the engine loses compression entirely due to stuck lifters or camshaft damage. The 5.3-liter V8 is one of the most affected, with multiple technical bulletins issued over the past decade. Ram Hemi 5.6 Ram's 5.7-liter Hemi engine is known for developing a ticking noise related to faulty lifters or cam lobes. Left unchecked, the ticking can escalate into full camshaft failure before 30,000 miles, especially in trucks that don't follow break-in recommendations. David Brackett, a Ram-certified technician, warns, "I've replaced multiple Hemi engines that failed before 25,000 miles. Most of it boils down to bad lifters from the supplier or improper oiling at startup." 4. Environmental and driving conditions. Early engine failure isn't always about the hardware. Environmental conditions play a big role. Trucks driven in extremely hot, dusty, or mountainous environments face higher engine stress. Likewise, repeated short trips that don't allow the engine to fully warm up can cause fuel dilution in the oil, leading to poor lubrication and internal wear. Towing heavy loads without proper gear selection or allowing time for engine cooldown after hard driving can also accelerate wear, especially in turbocharged trucks. 5. Owner mistakes that contribute to early failure. Truck buyers sometimes assume that durability means no maintenance required. In truth, modern trucks require more attention due to tighter tolerances and sophisticated systems. Common owner-related mistakes include ignoring the check engine light, skipping oil changes or using generic quick lube shops, overloading the vehicle beyond its rated capacity, using aftermarket tuners without proper tuning for fueling and timing, failing to check coolant or oil levels regularly. Dan Lasker, a diesel performance expert, adds, "Half of the catastrophic failures I see were preventable. It's often not abuse, but neglect, or just not knowing the new rules for modern engines." 6. What truck owners can do to prevent early failure. Despite the risks, there are practical ways for owners to protect their engines and avoid becoming a statistic. A. Follow maintenance. Buy the book, or better change your oil more frequently than the manual suggests, especially if you tow or drive in hot climates. Use manufacturer-approved fluids only. Keep records of every service. B. Watch for warning signs. Ticking, knocking, or oil consumption are not normal and should be addressed immediately. Early attention can prevent major repairs later. C. Warm up and cool down the engine. Allow your engine to reach operating temperature before hard acceleration. After towing or highway driving, idle the truck for a minute to let the turbo or cooling system normalize. D. Scan for recalls and TSBs. Even if you don't receive a recall notice, your truck might be covered under a TSB. Dealerships may fix issues proactively if you mention the bulletin code. 7. The warranty and Lemon Law angle. If your engine fails under 30,000 miles, it's likely still under powertrain warranty. But not all dealerships will replace an engine without a fight, especially if they suspect neglect or aftermarket modifications. In some cases, early engine failure qualifies for Lemon Law protection, especially if repeated attempts to fix the issue fail. Auto legal advisor Rachel Kim explains, keep detailed records of all service visits. If the engine fails twice or more under warranty and the problem can't be resolved, you may be entitled to a refund or replacement vehicle under state Lemon laws. 8. Conclusion: the complex puzzle behind engine failure. A truck engine failing before 30,000 miles is more than just an inconvenience. It's a failure of expectations, engineering, and sometimes communication. Whether it's due to manufacturing defects, overly complex systems, poor maintenance, or environmental stress, the causes are often layered. What's clear from expert analysis is that many failures could be avoided with better awareness, closer maintenance, and stronger accountability from manufacturers. As engines become more sophisticated, so must the ownership experience. It's not enough to assume that a tough-looking truck equals a tough engine. Today's engines need precision care and a little luck.